So in P4, we used SVD to factor PPMM matrices into the word vectors, which is a count-based approach. So in P5, we'll implement continuous bag of words, a prediction-based neural method. Instead of building a co-occurrence matrix, Seabow trains a neural network to predict center words from their context. This is the foundation of the word-to-vector family that revolves word embeddings. So the architecture of Seabow uses a simple neural network with one hidden layer giving context word like the, cat, sat. We average their embeddings to get a hidden representation. This hidden vector is multiplied by a weight matrix to produce logits over the entire vocabulary. So the softmax converts these two probabilities and we train to maximize the probability of the actual central word. The model learns embeddings that predicts words from context. So the forward pass is straightforward. First we look up the context word similarity. Thereafter, then we compute logist as W word and finally we apply softmax to get probabilities. The loss is the cross entropy. So this is the standard classification where prediction which word should appear in the central position. And the magic is the gradients. For W word, the gradient is the outer product of prediction target and the hidden vector h. For W context, we compute the gradient for h first, then distributed it equal to the context words. The key insights is that each context word gets the same gradients since they all contribute equally to the average. The code implementations these hand-delivered gradients without autograde pure NumPy. So the training uses stochastic gradient descent. We prepare training data by sliding a window over the corpus, collecting the pairs. For example, we do forward pass, compute loss, backward pass to get gradients and update weights with learning rate. The output shows loss decreased over approaches as the model learns to predict centered words from the context. We use a small vocabulary and few approaches for the fast training. And the main limitation is the softmax computing probabilities over the entire vocabulary at each step. So this is big O of mod v minus for 1 lakh of words, that's 1 lakh computations per training step. This becomes prohibitive for large vocabularies. The output shows timing information softmax domination training time. This is why word to vector introduced negative sampling and hierarchical softmax, which we will see in P6 and P7. Now let's go through the output. So initially it loads the tokens of 20,000 and thereafter the vocabulary size of 1,000. So it's a training samples of 18,439 with 3 approaches where from each approach the loss is minimized and the similarities are for man and woman is 0.8805. This is the complete execution. Thank you.